Hi, it's Naomi Andrick. I wanted to go over one more system of inequalities using graphing. So here we have a system of inequalities. Now these are two variable inequalities and there are four of them. So unlike systems of equations where you normally have the same number of equations as variables, systems of inequalities you can sometimes have several more inequalities. So I could have 5 inequalities or 6 inequalities if I really wanted to, even though there are only two variables. Because we know we're going to have several solutions anyway. It's not like we're just looking for one solution like we are for systems of equations. So here we're going to be graphing them. And I would personally, since these are essentially in standard form, I would graph them using the x and y intercepts. So let's see. Okay, so to find the x-intercept, I know that I'm going to let the y be 0, because on any x-intercept, the y part is 0. So I'd let this y part be 0, and I'd have x plus 0 equals 12. Well, what plus 0 equals 12? 12 plus 0 equals 12. So the x part's going to have to be 12, and the y part's going to have to be 0. Now, for the y-intercept, it works exactly the same way. Only, instead of letting the y part be 0, we're letting the x part be 0. So anywhere on the y-axis, x is 0. So x is 0. We already know that about the y-intercept. And then 0 plus 3 times something equals 12. Well, if 3 times something is 12. That something has to be 4. So our y-intercept here is going to be 0, 4. So now if I come over here to the graph, and I graph these points, I've got 12, 0, that's right here on the x-axis, and I've got 0, 4, that's right here on the y-axis. Looks about right. And then from there I'd actually shade. I'd probably wait, depending on how your teacher likes it or whatever. I would wait till the end to shade just the part that makes all of them true. But if you want to know what just this one inequality looks like, let's see. It would shade towards 0, 0, because 0, 0 does make it true. So it would shade this entire side. Okay, now the second one. Second inequality really works exactly the same way. So I'd find the x-intercept, find the y-intercept, use them to graph, and think about where I would shade. Okay, so with the x-intercept, like I said before, the y part will be 0, and the x part will be whatever number x has to be to make it equal. So if y is 0, we have 2x plus 0 equals 12. Well, if 2x is 12, then x has to be 6. So my point is going to be 6, 0, right there on the x-axis. My y-intercept, again, works exactly the same way. We let x be 0 because x is 0 anywhere on the y-axis. So this part of our equation would be 0. We'd have y equals 12. And so our y-intercept would be 12. So 6, 0 is right here. Yep, I'm still on shading mode. 6, 0 is right here. 0, 12 is right here. And then we know that for this one we'd shade it also down towards 0, 0. So if you wanted just that inequality would be shaded like this. Now, the last two, x is greater than or equal to 0 and y is greater than or equal to 0, we know x equals 0 is just the y-axis. So it would be right here. It's a vertical line through 0, the y-axis. And then y equals 0 is a horizontal line through 0, so it's the x-axis. And we'd shade them both towards the positive side. So this one would shade up, this one would shade over. So imagine all your shadings and where they would overlap. This one shades here, this one shades here, this shades positive, this shades up. It would be right here. But if you wanted to check, you would take this point 2, 2, and you'd put it in all your equations. Well, 2 plus 3 times 2 less than or equal to 12, yes. 2 times 2 plus 2 less than or equal to 12, yes. 2 bigger than 0, yes. 2 bigger than 0, yes. So it has to make all your